Ever feel like GCSE chemistry is just a massive pile of disconnected topics, feeling a bit overwhelmed? Well, today we're going to let you in on a little secret. Your secret weapon for revision, actually. It's section 4.11 of the AQS specification, and you should think of it as the master key to the entire subject. Seriously, what if I told you that there's one small section tucked away right at the end of the syllabus that gives you the fundamental code to understand everything else? That is exactly what section 4.11 is. It's not another chapter you have to memorize. Nope. It's the framework that connects literally everything, from atomic structure all the way to chemical reactions. And look, you don't have to just take my word for it. AQA says it right there in black and white. These ideas will be assessed across all papers. This is exactly why we're calling it the master key. When you get this section, you're not just learning isolated facts anymore. You're learning the actual rules of the game. It means you can apply these core principles to any question they decide to throw at you. All right, so we're going to break this down into two main parts. First up, the code of matter. This is all about the fundamental rules that decide what everything is actually made of, from the simplest little element to the most complex compound you can imagine. Okay, it all starts with the most basic idea of all. Everything, I mean you, me, the phone you might be watching this on, it's all made of tiny particles called atoms. And get this, with only about 100 different types of these atoms, which we call elements, we can build the entire universe. It's like the ultimate Lego set, right? Now, here's the cool part. These 100 or so elements aren't just a random jumble. Not at all. They follow a really clear pattern. The periodic table is basically a map that arranges them so that elements with similar properties line up neatly in columns or groups. And that's no coincidence. It's a fundamental rule of chemistry. Take a look at the noble gases in group 0, for instance. As you move down the group from helium to argon, you can see the boiling point steadily increases. This predictable trend is a perfect example of what we call a periodic relationship. You can find these patterns all over the periodic table, and they're super useful for predicting how an element is going to behave. So, why do these patterns even exist? Well, the answer is hidden inside the atom itself. An element's properties and its specific address on the periodic table are all decided by its atomic structure, and more specifically by the arrangement of its electrons. See, elements in the same group have the same number of electrons in their outer shell, and that is what gives them their similar chemical personalities. So if the number of outer electrons determines how an atom acts, what happens when atoms actually meet? Well, they bond. And they basically do it in one of two main ways. Either they completely transfer electrons, kind of like a trade, or they share them, more like a partnership. This one simple concept is the foundation of every single chemical compound. Let's put them side by side. On one hand, you have ionic bonding. That's the transfer. A metal atom gives away its outer electrons to a nonmetal atom. This creates oppositely charged ions that then attract each other. On the other hand, you have covalent bonding. That's the sharing. Two nonmetal atoms share electrons to form a strong bond, creating these distinct little particles we call molecules. Transfer or share, that's the choice. And finally, for this part, how these atoms are bonded together dictates the whole structure. A few atoms covalently bonded make a small molecule, like water. Billions of ions ionically bonded create a giant lattice, like table salt. And this structure, whether it's a tiny molecule or a huge crystal, determines the substance's properties, like its melting point or whether it conducts electricity. Shape really is everything. Okay, so that was the code of matter, basically what stuff is. Now for part 2, the code of reactions. This is all about the rules that control how substances change, how they interact, and how they transform from one thing into another. The first huge idea here is that chemical reactions aren't just instant. For particles to actually react, they have to collide with enough energy to get over a barrier. We call this the activation energy. You can think of it like the minimum height you have to jump to clear a hurdle. Some hurdles are really low, so the reaction is fast. Some are really high, which makes the reaction much, much slower. And the best part is, we can actually control the speed of that race. By changing things like the temperature or the concentration, we can change how often and how hard the particles are colliding. More frequent, more energetic collisions mean more particles are successfully clearing the activation energy hurdle, and so the reaction speeds up. That's the heart of collision theory. Now this simplifies everything. Believe it or not, according to the specification, pretty much every single reaction you'll study happens in one of just 3 ways. It's either a proton being transferred,
which you see in acid-base reactions, or it's an electron transfer. That's the basis of all redox reactions. That one idea explains everything from rusting to how batteries work. And the third way is simply electrons being shared to form new covalent bonds. That's it. Master these three, and you've basically mastered chemical change.
And the final piece of the puzzle is energy. It's the law. Energy cannot be created or destroyed in a chemical reaction. It just gets moved around. If a reaction releases energy into its surroundings and heats them up, we call it exothermic. If it absorbs energy from the surroundings, cooling them down, it's endothermic. But the total amount of energy always stays the same. So there you have it. We've gone through the 8 key ideas. But how does all this become a practical tool for your revision? How do you actually use this master key? Here's exactly how you use it. Go and organize your revision notes under these 2 simple headings. For any topic you study, just ask yourself, is this about what matter is, or is it about what matter does? Is it about atoms and bonding, or is it about reaction rates and energy? This framework helps you connect all the dots. You can link the electron structure of an alkali metal, for example, directly to its explosive reaction with water. It helps you build a complete map of chemistry in your mind. And never forget this powerful statement right from the spec: universal application. These are not just niche little rules for specific topics, no way. They apply to everything. They are the fundamental principles that govern the entire subject. So when you're stuck on a really tough question, come back to these ideas. They're your first principles. See, the key isn't just knowing these ideas exist. It's about actively using them to structure your revision and to attack exam questions. So the final question is for you. How are you going to use this framework to connect the topics, deepen your understanding, and walk into that exam hall with total confidence?